Trying out a slightly different wording this time. I'm going to start with the phrase, one can geometrically interpret the set. And then there's the description of the set, right? So one can geometrically interpret the set of ordered triples x, y, and z in R3 such that x squared plus y minus 1 squared plus z squared is equal to 4 and y is equal to 0, which is equal to the set. Okay, so y is 0. I've just put in 0 for y. X, 0, z in R3 such that x squared plus, hey, if I replace y with 0, then I just get a 1 right there, plus z squared is equal to 4. Okay, so now I'm just going to simplify that equation. This equation right here, which is part of the description of the set, it's going to just look like x squared plus, well, z squared is equal to 3. And then, oh, this is a circle. And I could say this is simply x, 0, and if I rearrange that algebraic equation for z in terms of x, I would have z is plus or minus the square root of x squared, no, 3. 3, all I'll do is square root of 3 squared, that way I can, okay, sorry. Yeah, square root of 3 squared, that's just 3, minus x squared. Okay. Safe territory, such that x is, well, any old real number, right? Except x can't be too large, can it? Such that x, right. Here I cannot take x to be, say, 4. Yeah, because I'd have 3 minus 4 under the square root. So I think I need for x to be in the interval negative square root of 3 to square root of 3. I think I forgot that on an earlier video where I also had a circle. I think it was just the last video I did, number 5. So go back and fix that. I made a mistake. That's alright. At least I learned from it. Okay, so what do I have here? This is a set of ordered triples of that form. I've got a sense that this is a circle. Let me name this guy. I'm going to give it the name, so which I'll define as, let's see, I'm going to call it C again for fun. And the reason I've chosen C is because this thing's going to be a circle. One can geometrically interpret this set as the circle. Now I got to describe the circle. The circle, let's see, it is in the y equals 0 plane, which is the xz plane. And where is the center of this thing? Center at, So, looking right here, it seems to be centered at the point 0, 0, 0, as drawn below. Okay, so here's my usual 3 axes. That's the y direction, the z direction, and of course, as usual, that's the x direction. Now, I'm going to always have y is 0, so I'll always be in this left wall, as I like to call it, the wall in there. And oh, I forgot part of the description of the circle. I forgot the radius of radius square root of 3. I could say with 3 is square root of 3. But sorry I had to squeeze that in. Let's see, where the heck is square root of 3? I will say about there. Right? Square root of 3. And similarly, square root of 3 up on the z-axis should be there. Let's see, square root of 3 is a height. And 0, 0, 0, the center right there. Okay, so I need to draw a circle that passes through this, this. Also, there's a point down here somewhere behind my stinking number that I drew. No good. Why did I do that? And then I'll try to draw a negative square root of 3 back on this guy, maybe over here. Negative square root of 3 on the x-axis. And so I've got to draw a circle that goes through this point, goes down and goes through somewhere back there, and hits a point down there, and then comes up, passes behind that, goes to this point, and then back around to there. Hopefully it feels like what you're seeing is in the XZ plane. And you know, you make some mistakes in life. I made the mistake of writing the number square root of 3 right there where my circle was going to go through. I could do better next time, I bet. Also, I uglified this quite a bit. Oh, man. So, now that you've watched the video, maybe you can do better.